All right, section 7.3. We're finally getting to the guts of chapter 7. So we talked about exponentials in the first couple sections, and now we're going to talk about their inverse function, which is called logarithms, often abbreviated by just log, right? Because honestly, most people can't spell logarithm anyway, so we're just gonna go with log as the abbreviation. And this is very likely the first time you've seen this. So our goals for this lesson are just to understand logarithms a little bit, like what the heck they are. Kind of confusing the first time you see them. And then we're going to change between log and exponential forms since they're inverse functions. We got to learn how to convert between them. And this is actually maybe the most important skill that we do in the whole chapter. I sometimes tell kids don't even show up for the test if you can't do this, right? Because you're going to be in world of pain if you can't convert between them. And then also how to do a little bit with them on the calculator. That's kind of the third goal. So without any further ado, what the heck is a logarithm? All right, so if you want to write down some examples, maybe let's do that before we get a formal definition. So log has a little number down here, okay, and it's not an exponent or anything. It's just like a subscript and then a value. And so this thing down here is the base. And so what a log really says is if I have a base of 7, what is the exponent that'll give me this number right here? So in this case, what is the exponent that'll give us 49? Okay, and so this log evaluates to 2. Log base 7 of 49 is 2. So one of the ways that I think of logarithm, if you want the Mr. Westphal definition, logarithm is find the exponent. Okay, and if you want to put in parentheses for a given base. Right, so that's what I always think of when I think of logs. So the second one, I don't know, see if you can figure it out. If you can pause the video and get this, then maybe some of my rambling made sense. All right, so this one says a base of 2. What is the exponent? That'll give us 16. And so the exponent we need there is 4. Okay, and if you're not sure how to figure that out mentally, I kind of just do guess and check. And long term, we'll be able to do this on our calculator. So not a big deal if you can't quite do that in your head. Okay, and then the last thing you probably want to note is an example like this. And so just put in your notes that if nothing is written, it's assumed to be base 10. So if nothing is written, the default is 10. Okay, so if it just says log with no little number there, then it just means a 10. So we can sort of add it in here. You can do it a little dashed 10 if you want. That didn't show up very well, but it's basically an implied 10. So this one says 10. What is the exponent for base 10? That'll give us 100. And the answer to that is 2. Right? And that's called evaluating the logs, is finding the value, finding the exponent, essentially. All right, just a little bit more information about what a logarithm is. So log form has the 3 parts, right, over here. And I would definitely write down this form and then write down what they mean. So B stands for the base. Y is the exponent, because log means find exponent. So on the other side of equal sign goes the exponent. And then X, I'm oftentimes just going to call the value, right? And so you're more used to it in this exponential form. So this statement in equivalent form is over here. And here's our base, right? So we have our base exponent pair like you're used to. Hopefully those terms are familiar with you. And then you raise that base to the exponent, like 4 to the 3rd power or something, and then that gives you a value. So in the regular form, you do the base to a certain power to get a specific value. And log is just a different sort of way of writing that. All right, and so we need to be able to convert between these forms. All right, so a couple notes. They are equivalent. You're going to hear me read this or say this a lot. So log b of x is read log base b of x. All right, and then our definition again is like, what is the exponent for this base? All right, and then eventually to know that they're like opposite functions. So if you, took a number like 5 and then squared it, and then if you did like the log base 5 of that value, which I guess would be 25, that'll get you the exponent that you started with in this case, 2. So basically, they undo each other, just like addition is the opposite of subtraction. Logs and exponents are inverse, I guess I could say, of each other, inverse or opposite, however you want to say it. All right, so next thing in notes is to make a big chart like this, a T-chart in your notes, and I'm going to have a bunch of examples coming at you. Okay, so we got to know how to convert between the two forms. And so write down these examples and then see if you can convert some already. Right, if not, maybe watch the first one and then pause the video and try the others. But if you feel like you got it, try it right now. See if you can convert. Okay, so here we go. So I always do the base here. This is my base. And then log means find exponent. So that's my exponent. So I do base, exponent, and value of 9. So for me, I always start with the base and exponent because those are the easiest two for me. So the base is a little number here and the exponent's there. So I write base of 5, exponent of 3 equals value 125. Okay, and these statements should make sense, right? Like 3 squared is 9. Like if I did something weird, like if I did 3 to the 5th equals 125, hopefully some warning bells are going off that those two things aren't equal. So something, something went wrong there. All right, last one is when we start to solve, right? This one has an x in it, so we could think of this as like solving the equation. So when you solve, the key is going to be able to switch form. So on this particular one, I'm going to say a base of 5, right? Base exponent, base of 5 exponent of 2 equals the value x, right? And then boom, you're done, right? If you can do that, convert form, you've already solved the equation for x, right? 5 squared is 25, so the right answer there is 25. So long story short, when we solve, being able to switch forms is going to be the key. All right, try some going the other direction. These are in exponential form. See if you can write them in log form. All right, so I'm going to start off by writing the word log, and then the base in this case. So here's my base, and that's my exponent. So it's going to be a base of 2. The base is a little number, and log means find exponent, so that goes here. And then I fill in the value last. All right, same thing here, log. I'm going to write the little base and exponent. So it's base of 3. Log means find exponent, so that goes there. And then the value 243 goes there. Okay, and again, some of you could maybe solve this mentally and just know that this is 3, right? Some of you could probably just tell that x has to be 3 there. But on a harder question, we're going to switch form. So it'll look like log, right? The base is 5. And log means find exponent. So x goes over here, the exponent, and then 125. Okay, and then it's really just a matter of being able to do this on our calculator, and we'll solve it for x. And actually, maybe I'll show you how to do that real quick. Yeah. So there's a special, like basically on your calculator, the regular log button here does base 10. So if I do log of 100, that's going to be a base of 10. So the exponent there is 2. And if you need to do a non-base 10, I forget how to find this, but let's see if we can find it in math. And let's see. Yeah, there it is. So I scrolled up. So from math, I went up, and there's this log base thing. And I'm going to hit that and then type the base first. So our base was 5, and then our value was 125. And that should get us our exponent of 3. So again, that's under math and log base right there. Can get you a non-base 10, right? But if you have just a regular base 10, you can just use the log button that's right on the side of the calculator there. Okay, so this came out to be 3. So when we solve, again, we're going to want to convert forms. All right, let's try a couple weird ones. Pause the video and see if you can convert the forms. Okay, so these are all true statements. 1/3 to the negative 2 power is 9. And you can, again, type in your calculator if you're not sure. But at any rate, I'm going to do log. And now my base is actually this fraction, right? Here's my base and exponent. So my base is 1/3. And log means find exponent, so the exponent goes here, and then the value 9 goes there. So log of 1/3, log base 1/3 of 9 is -2. Okay, same thing here. So I'm going to do log and then the base. So again, I'm going to label them. Here's my base, there's my exponent. So my base is 1/4. My exponent is 3. and my value is 1/64. All right, going the other way. Here's my base and exponent, base and exponent. So I'm going to do base of 4, power of 2.5 equals 32. And again, that should be a true statement. If I didn't do it right, I'll get a weird statement that's not true there. Okay, so this objective I talked about earlier is the most important thing in this whole chapter. So in order to ensure that you've got it, I made a little assignment where you practice converting between the two forms, and it'll be out there somewhere on Schoology. This is how I used to set up Schoology, so this might be a little bit different, but now it's probably in the 7.3 folder. But look for this little thing, and before going on in the video, practice this. Make sure you can get at least 9 out of 10. Obviously, I can't send you candy, but maybe your parents can give you a cookie if you do this really quickly. All right, so try that before going on with the video. So final thing is really just to be able to evaluate logs, and we already kind of talked about this. So like, you can do some of them mentally. Like this one is really, I always kind of do the other form. What's the exponent for 10? That'll give me 100, right? So that's 2. You could think about this one. Actually, try the other ones quick before going on. And you can either do them on your calculator like we showed before, or just kind of do them mentally like this. So all of these I can do mentally still. This is an implied base 10. Remember, if nothing's written there, it's base 10. So this is saying 10 to what power will give me 1,000. So I need a power of 3. 10 times 10 times 10. Right? And this one is what power for 2 will give me 8. And that should just be 3, right? 2 to the third. The last one, again, is 5 to what power, gives me 25. And that should just be 2. Okay, and so again, maybe you're saying, you know what, Mr. Westphal, I'm not a math teacher, so I can't do all this stuff so easily in my head. So let's try a base 10 one. So let's do log of 1,000 and this log base 2 of 8 on our calculator. Okay, so for log of 1,000, it's pretty straightforward. You just use the base 10 button, right? So log, and again, it's not showing the 10, but it's an implied 10. Okay, and then the log base 2 of 8, again, you have to do math, go up to log base there, and I'm going to type 2 and value of 8, and then enter. Okay, and we get 3, right? Just like we got doing them mentally. Okay, so final thing I want to mention is there's something called the change of base theorem, which I do think they ask you about it on the test. So we just did log base 2 of 8 with our fancy button on our calculator. But if you didn't have that button, maybe you got an older calculator or something, you can still do a non-base 10 log by doing what's called the change of base theorem. And how that works is you make this log base 2 into 2 base 10 logs. That's why it's called change of base, because it goes from base 2 to base 10. Okay, and what you do is you take whatever number's here and do the log base 10 of that on top, and then you log base 10 of this on the bottom. Okay, and if you type that in your calculator, you should get 3 like we did before. All right, so let's try that out. So we just did it here with the regular button, but if I do log of 8 divided by log of 2, that'll be 2 base 10 logs, and that should give me the same thing of 3. Okay, so that's called change of base. All right, so I just want to make sure you got it. So see if you could rewrite these. What would you type in your calculator if you wanted to do these with change of base? So pause the video and give them a shot. All right, so the key is whatever number is up here goes up, and whatever number there goes down. So this would be log of 30 over log of 3. Okay, this one, again, the 6 is the little number going down, so we do log of 6 over log of 154. Okay, and then this last one, again, the little base is going to go down, so this would be log 7 over log of 149. Okay, and again, you can use the log base button on your calculator, or you can just type them this way, especially if you don't have a fancy log base calculator. Right, so that concludes logs, right? It means find the exponent, and hopefully you learn a little bit about how to switch forms and how to evaluate them. Thank you for watching.